Now, as you are aware what set builder form and roster form is, let us take some examples from the exercise of the same type so that you understand the concept of these two representations properly. So in exercise 1.1, question number 3, we'll get back to the previous questions later. First, attempting questions based on these two representations. Question number 3 is write the following sets in roster form. You can see some of the cases I have taken. We'll convert them into roster form. Question number 4 is write the following sets in set builder form. Again, 4 parts I have taken. We'll convert them into set builder form. Now look at these 4. These are all in set builder form. We have to convert them into roster form. That means whatever X is, that is to be listed here. Okay, so we'll see the conditions which are applicable to X and accordingly we will write its value. Okay, solving for the first one. The set says A is a set. We use capital alphabets to denote the sets. It says set A contains an integer X which is greater than equal to -3 but strictly less than 7. When we say greater than equal to, that means it can be equal to -3 or an integer greater than that. But here you see it is less than 7. So 7 is not included. Over here -3 is included. But here 7 is not included. This is called strict inequality. Strictly less than 7. Okay. So let us use these two conditions and try to write the possible values of X. So X can be -3. Integer greater than that -2, -1, 0, 1, 2, 3, 4, 5 and 6. These are the possible values of X. You can see these are all integers. And the integer is greater than equal to -3 but strictly less than 7. So all the numbers are listed within the braces we have written and they are all separated with comma. So A is converted into roster form. Okay, coming to the next one. B contains the elements X which are denoting natural numbers less than 6. So natural numbers which are smaller than 6. We don't need to tell what it is greater than because we all know 1 is the smallest natural number. So when they are saying it is a natural number less than 6, it means it will include 1, 2, 3, 4 and 5. Okay. Then coming to C. C is denoting those 2-digit natural numbers such that the sum of the digits is 8. So when you are adding the digit at 1's place and the digit at 10's place, the sum should come out to be 8. So this is how you have to think about 2-digit natural numbers. We know smallest 2-digit number is 10. But the sum of digits is not 8. So we keep on thinking. And we'll start with the one where the sum of digits becomes 18. You will find 17 is the smallest natural number where the sum of digits is 18. You can see 1 plus 7 is 18. We'll keep on proceeding. After this, 26 will give us the sum of digits 8. Then we have 35. We can have 44. We can have 53. Then we can have 62. We can have 71. Is there scope for something else? Another 2-digit number where the sum of digits is 0? It will be 80. 8 plus 0 is 8. So these are the 2-digit natural numbers where sum of the digits becomes 8. So converted into roster form. Now look at this one. I have not used braces here. Why we have not used braces? Because we are already writing the set. We are telling it is a set. So we don't need to use the notation. So E contains the set of all letters in the word trigonometry. See, purposely I have taken this word because when you list the alphabets from here, you will find some of the alphabets are getting repeated. Now, when we list the alphabet or number, whatever, the order is not important. You can write any alphabet or number first and the other one later. If I talk about this, here we have maintained the ascending order. Here I have maintained the ascending order. But order is immaterial. It is not important. Okay, but something which is appearing more than 2 times, it is coming 2 times or 3 times, has to be written only once. Okay, let us start writing. I'll start from the left to the right. You can see T is coming 2 times, but we'll mention it only once. So T is one of the letter. R comes twice, we'll write it once. Then I, then G. O is coming 2 times, so we'll write only once. Then N. O we have already written. M. Then E. T is done, R is done, so it is Y. So the word trigonometry consists of these letters. Okay, some may be coming more than once. So these were some examples of roster form. Now coming to set builder form, if you look at all these sets, they are written in roster form. So you will see what is common among the elements of these sets, and accordingly you will try to write it in these forms. Okay, defining their property. What is common among all these? If you see, these are multiples of 3. This is 3 into 1, this is 3 into 2, 3 into 3, 3 into 4. So I can write it as the elements of A are denoted as X. Where what is the nature of X? X is 3 times N. 3 times N. What is N here? N belongs to natural numbers and N is less than equal to 4. Okay, let us compare these two. So when I say N is a natural number less than equal to 4, so the possible values of N are 1, 2, 3 and 4. So when N will become 1, 3 into 1 will be 3. When N will become 2, 3 into 2 will be 6. When N will become 3, 3 into 3 will be 9. And when N becomes 4, 3 into 4 will be 12. Okay. So we have completely properly defined what is the other way of writing set A. They both are same if you see, only written in different form. Okay, let us apply the same here for B. Look at the elements of B. These are higher powers of 5. This is 5 raised to the power 1, 5 raised to the power 2, 5 with the exponent 3, 5 with the exponent 4. So we can define it. Now we can say the elements of B are denoted by variable X, where X is of what type? 5 to the power N. What is the nature of N? N is a natural number and it is less than equal to 4 again. We don't have to tell it is greater than or greater than equal to, because we know when it is a natural number, its smallest value is 1. So see, if N will become 1, this is 5 raised to the power 1, 5. When N will become 2, it will become 5 square. That means 25. If N is 3, then it will be 5 to the power 3. That means 125. And 5 to the power 4 will be 625. So done with B. Okay, look at C. C is an infinite set. Multiples of 2. 2 into 1, 2 into 2, 2 into 3, or even numbers you can simply say. So I can write it in two ways. Firstly, I can write it as X such that X is equal to 2N, where N belongs to natural numbers. Nothing else to define because it is infinite. When N is 1, it will be 2. When N is 2, it will be 4. When N is 3, it is 6 and so on. Okay. Or we can even write it as the set of even natural numbers. That can also be written. Okay, we are using all the even natural numbers. So obviously it starts with 2. Okay, then see the last one. D. What do you find common among these? These are perfect squares. Square of 1, square of 2, square of 3, square of 10. So there are 10 elements if you see, all perfect squares of natural numbers. So we can write it as X such that X is square of N. And what is N here? N is a natural number and it has got a restriction. N is less than equal to 10. So we have squares of natural numbers, but the highest value of N is 10, because square of 10 will become 100. When N is 1, it becomes square of 1. When N is 2, it becomes square of 2, that is 4. When N is 3, it becomes square of 3, which is 9. And when N will become 10, it is square of 10 which becomes 100. I think you must be able to understand by now how the sets can be represented either in roster form or in set builder form.